All right, in this video, we're going over standard form of a quadratic function, and this is part one of a two-part video. All right, here's your vocab. Your vocab for this is simple. It's simply standard form. What is standard form? Well, standard form of a quadratic function is f of x equals ax squared plus bx plus c. So make sure you write that down. Standard form is important. You'll see quadratics written in standard form the majority of the time. All right, number one, finding the features of a quadratic function using the graphing calculator. It says what are the vertex, the axis of symmetry, the maximum or minimum value, and the range. All right, so if we flip over here to the Inspire, here we have our function graphed. I went ahead and graphed it. 2x squared plus 8x minus 2. Now, we can use the table feature to find the minimum as well as the range and the vertex and things like that. So if you remember, to get to the table, you simply go Control T and it'll pop the table up. Now, so we're looking for the min. For the mins right here, it looks like it occurs at about 2, so we can scroll, about -2, so we can scroll up in the table. Oh, there we go, right there. See how it goes -8, -10, and back to -8? And so that tells you that -2, -10 is in fact our vertex. All right, so let's flip back over here and write that down. We know that the vertex, all right, is -2, comma, -10. All right, because if you look at the graph, that is where it looks like it turns around. So we have -8, -10, and now we're going back up. So at -2 is where it turns around. All right, the next thing we wanted, let's go back, was the axis of symmetry. Well, that's easy because the axis of symmetry is simply x equals the x-coordinate of your vertex. So our axis of symmetry is simply x equals -2. Now, the maximum or the minimum value and the range. Now, remember, you only have one. You either have a max or a min. You don't have both. And it's going to be y equals some number. So let's flip back to the calculator. We're looking for our lowest y value. Well, if you notice, it never drops below the vertex. All right, so our minimum does occur at the vertex. So we have a min, and it occurs at y equals -10. That is our minimum. Now the range, if you remember from today, we were talking about that the range is all the possible y values that you can get out of the function. Well, if the smallest y value that we can get out of the function is -10, then that means our range y has to be greater than or equal to -10, because we've already determined that -10 is our smallest value that we can get out of the graph. So therefore, our range has to be all the y values that are greater than or equal to -10, because -10, of course, has to be the smallest value. All right. And again, we found that by simply graphing our function and then choosing Control T to bring up our table, and then we simply found in our table where the graph turns. All right, we found out where it turns. We noticed the symmetry, -8, -8, -2. If we scroll down just a tad here, -2, and then 8. If we go up here, 8. So we found the symmetry, so we know that -2, -10 had to be our vertex. All right, and we also know that it's a minimum by looking at the graph. We know it's a minimum. We know our axis of symmetry is always equal to the x-coordinate of our vertex. And then our range, since this was a minimum, our range is greater than or equal to -10. All right. So here's some properties of a quadratic function in standard form. So, of course, the graph of f of x equals ax squared plus bx plus c, where a is not 0, is a parabola. We know that. If a is greater than 0, we know that it opens up. If it's less than 0, we know that it opens downward. Now, you can pull the axis of symmetry straight from standard form. We don't have to try to solve it. We don't have to try to get it in any kind of special y equals form. We don't have to graph it. We can simply pull it straight from here. All right, we can simply pull everything we need straight from here. So the axis of symmetry is the line x equals negative b divided by 2a. All right, negative b divided by 2a. So if we had a function here, we could simply do negative and then do b minus 2 times a, or b divided by 2 times a, and get the x coordinate. Now, that's the line of symmetry. That's also the x coordinate of the vertex. All right, make sure you're writing this down. We'll do a problem with this in just a minute. All right, so the x coordinate and the line of symmetry, you both find by negative b over 2a. Now, to find the y coordinate of the vertex, you simply take what you get for your x value, plug it into here, and the number that it spits back out, that is y. That's what this means right here. F evaluated at negative b over 2a. All you simply did was found your x coordinate and then evaluate it, so plug it in, and then whatever you get out, that's your y coordinate. And then of course the y-intercept is simply 0, c. All right, here's a couple of graphs that represent that. But let's go to the next slide and actually use some numbers for this, shall we? All right, so graphing a function of this form. So what is the graph of y equals x squared plus 2x plus 3? Well, first thing, let's find our vertex. And then our axis of symmetry, okay? And we know that this is going to be x equals. So we know that negative b divided by 2a will give us not only our axis of symmetry, but the x coordinate of our vertex. So let's go ahead and evaluate this. So we're going to have b is 2, a is 1, and then I'm going to do c is 3 just so we have it. All right. So negative divided by b, which is 2, over 2 times a. Well, a is 1, so 2 times a is just 2. So negative 2 over 2 is simply negative 1. All right. So we take the negative 1. We know that's the x of our vertex. We also know that's our axis of symmetry. Plug the negative 1 in here. We get negative 1 squared plus 2 times negative 1 plus 3. So that's 1 minus 2 plus 3. And 1 minus 2 plus 3 equals 2. So there's our y coordinate. So now we have our vertex and we have our axis of symmetry. Next thing, let's find our y-intercept. All right, our y-intercept is simply 0, c. So that's 0, 3. So now we have our vertex, we have our axis of symmetry, and we have our y-intercept. So let's graph this. I'm going to move this out of the way, put it down here so you can still see it. And let me get a coordinate grid here real quick. There we go. Forgot to put this in here when I was setting all this up. All right, so now we have our vertex, negative 1, 2. So let's plot that. Negative 1, 1, 2. Here we go. Negative 1, 2. We know our axis of symmetry is x equals negative 1. All right, we know our y-intercept is 0, 3, 1, 2, 3. Well, we know that every point on one side of the parabola mirrors over to the other side of the parabola. So what we can simply do now is take this point and mirror it across our axis of symmetry, and now just draw a smooth curve. So there we go. Do we need to find any other points? No, we don't have to. If we want to make it more accurate, we can try to find some more points, but we don't have to, because we know that the left side of the graph is a mirror image of the right side of the graph, And in this case, we knew what our y-intercept was because we found it earlier. We knew that was 0, 3. So we were able to just simply mirror that across the axis of symmetry and then simply draw in our parabola. All right, and simply draw in our parabola. So, pretty simple, right? I want you to graph this one, and please do not do this with a graphing calculator. Do it by hand like we just did the previous one. Start off by finding the vertex, okay, which will also give you the axis of symmetry, and then find the y-intercept. Go. All right, while you're doing that, I got me a coordinate grid out. So our vertex, we know our vertex, or the x-coordinate of our vertex anyway, is negative b over 2a. We know that this is negative 2 is a, b is 2, and then this negative 5 is c. So negative b over 2a is simply negative b, well, I mean b, which is 2, over 2 times a, which is negative 2. So this is negative 2 over negative 4. The negatives cancel, leaving us with 1 over 2. So we know that our axis of symmetry is the line x equals 1/2, and that our vertex is 1/2 comma something. We need to figure out the something. All right. So we plug in the 1/2 into our equation. So we get negative 2 times 1/2 squared plus 2 times 1/2 minus 5. All right. And when you plug all that in, you are going to get, let's see, negative 2, 1/4, plus that cancels to 1, minus 5. So this is negative 2 over 4, plus 1 minus 5. Well, so we have negative 1/2 minus, what is that, 4, which equals, we need to get a common denominator, so this is going to become 8 over 2. So this is negative 9/2. All right, negative 9/2, which is what, 4.5, negative 4.5. All right, and our y-intercept, we know our y-intercept is negative 5. So let's see, 1/2, negative 9/2. So 1, 2, 3, 4.5. There we go. That's our vertex. We know this is our line of symmetry. That's terrible. That's a straight line, guys, trust me. All right, we know that's our line of symmetry. We know our y-intercept is negative 5. 1, 2, 3, 4, 5. We know this is going to mirror over. It's going to mirror over, so it's going to come over here and be right here. Because remember, we're a half unit that way, so we go a half unit that way. Now, technically, we don't need any more points. We have enough. So, this is terrible. I'm bad at drawing on this thing. And there we go. There's your graph. That's what your graph should look like. So, just to review, when you have your equation in standard form, negative b over 2a is the x-coordinate of your vertex as well as your axis of symmetry. And then to find your y value of your vertex, you simply take your x-coordinate of your vertex, plug it into your function, and the value you get out is your y value of your vertex. And then c, which is the constant on the end, is your y-intercept. And once you have the vertex, the y-intercept, and your axis of symmetry, you're set to just mirror the y-intercept across your axis of symmetry. And then you have 3 points, so you can go ahead and draw in your parabola. All right? So that's been standard form of a quadratic function, part 1. Feel free to watch this video as many times as you need to. Make sure you come tomorrow ready to work some problems. See you tomorrow.